Hello. In this video, I describe how lunar gravity affects Earth satellite orbits. I think you'll find it very interesting because it's not immediately intuitive. The image on my right was copied from Wikipedia. It is that of tidal forces on Earth's oceans due to lunar gravity. In this image, the circle represents the surface of Earth. The blue arrows represent lunar gravity on the surface and center of Earth, and the red arrows represent the lunar gravity perturbations that affect ocean water levels on the surface of Earth. To get the lunar gravity perturbations represented by red arrows, we must subtract lunar gravity at the center of Earth from the lunar gravity at the surface locations. Why? It's because Earth is also being accelerated toward the Moon, and it's your reference point for measuring gravity. Suppose you are on the surface of Earth with the Moon directly overhead. You are closer to the Moon than the center of Earth is. Therefore, you experience a larger pull from the Moon than Earth does. Effectively, you weigh less when the Moon is overhead. Since ocean water also weighs less here, the result is high tide. Now suppose you are on the surface of Earth opposite the Moon. The center of Earth is closer to the Moon than you are and, therefore, experiences a larger pull from lunar gravity than you do. Relative to Earth, then, you feel an opposite pull from lunar gravity. You, again, weigh less than you would without the Moon. Again, high tide is the result when the Moon is on the opposite side of Earth. It's just not as high as it would be on the other side of Earth. This explains why there are 2 high ocean tides per day. The same thing occurs for satellites orbiting Earth. Note that I've changed the previous image to demonstrate this. In this new image, Earth is shown at the center, and the outer ring represents the satellite's orbit. In summary, to include lunar gravity perturbations on satellites, you must find the gravitational acceleration due to the Moon at the center of Earth, and then subtract it from the gravitational acceleration due to the Moon at the satellite. If the satellite is close to Earth, the 2 subtracted vectors are nearly the same in magnitude and direction, resulting in a small gravity perturbation vector relative to the gravity of Earth, and can sometimes be neglected for short-term simulations. When the satellite is near Earth, Earth's gravity dominates, and its orbit is only slightly affected by lunar gravity. When a satellite is near the Moon's gravity dominates, and its orbit is only slightly affected by Earth's gravity. If you find this video useful, please give it a like. If you find this YouTube channel useful and want to be notified when we add more videos, click on the notification bell. Finally, leave a note if you have comments or requests for new videos. Goodbye.